Is it visible, my screen?
Yes, it's visible.
So Krishna, you can start introducing Jayanti.
Jayant sir is there?
Hello, excuse me. Dear Jayanti, are you there?
I think he's there.
Yes,
Hello.
I can hear.
Okay.
Can you
But
hear my voice also?
yes, Jayanti, I
Yes,
can hear.
yes, sir. So I'll just take a few minutes, sir, to introduce you. Your so that participant can understand a little bit about you. Um, Once again, welcome to this session, sir, and the participants. The second session for today's. So now, let me, without further delay, let me introduce Jayant Kumar Nath. So it is my and privilege to introduce our esteemed speaker for today's session, Jayant
Excuse me,
Nath.
Jayanti. Yeah, Krishna.
Hmm?
Recording is on?
Yeah, I think it's so. Yeah, it's.
It's
I
on.
did.
Okay.
Okay.
Thank you.
So it is a privilege, once again, let me start. It's privilege to introduce our esteemed speaker for today's session. That is Jayant Kumar Nath. He's a distinguished structural engineering with over 14 years of experience in structural design and specializing in railway, metro, highway, and bridges, or also that industrial buildings. He holds his master's and bachelor from IST Sipur, West Bengal. Just a minute. And has worked extensively both in India and overseas. So his expertise spans the design of superstructure and substructure, including pile foundations, piers, PSC, precast, and then are many more different girders and then beams, and also associated with different codes, guideline. And currently serving as a senior bridge engineering at MMSB consultant, SDN BHD Malaysia. So he has contributed to the major infrastructures projects such as Kuching Urban Transport Systems, Chennai Metro Rail Phase 2, and also the Malaysia East Coast Railway Link. And there are also link rail in transit. So the huge work he has done. So I have given a few things here. So his work also involved the construction support and design alternation, cost optimization strategy for large scale project. Beyond his professional contribution, he has played a crucial role of design basis reports and foundation, also the design evaluation and construction feasibility studies, ensuring the efficient and sustainable engineering solution. We are honored to have him with us today. I invite you all to join me and in welcome Jayant Kumar Nath to share his valuable insight and expertise. Though this is the, first talk by Mr. Jayant Kumar Nath, but we appreciate your cooperation in case of any inconvenience. Thank you. And may I now invite our distinguished speaker, Jayant Kumar Nath, to lead the session. Over to you, sir.
Okay, thank you for brief introduction, but it is quite huge.
No,
Yeah.
I have checked your CV, sir, but I have just taken a few of things to introduce. But yeah, this is a great, sir. Please.
Good afternoon, everybody. I am from industry side. I never give such type of talk or some type of lecture presentation to. It is my first time, so anything something wrong, I talk because I am long time discharged from the study books and all everything. I am just serving as a bridge engineer, and various type of component of the bridge I have designed. but theoretically maybe something may I get wrongly spell or something. Just excuse me. I just want to share my screen. Uh, is it visible my screen to everyone?
Yes, yes.
Yes, yes.
Okay, nothing to talk about me. Everything explained by uh, Dr. Krishna, and Janarul is one of my best friend. He invited me to give some real time industrial problem, and whatever we do in the design to something share my experience with all of you. So I just want to start. Okay, mainly uh, this my scope of work is the bridge design from top to bottom, means superstructures, substructures, and foundation. My today's talk, I not limited to only foundation because I am structural engineer, geotechnical engineer. They do the soil analysis and give the soil parameters, and also they do the pile design up to that. And from above means pile cap and substructure and all superstructure, all type of component done by structural engineer, me and my group of team. So we start with the foundation, and then I also go to the bridge, every part of bridge, how we design and how we provide the drawing to the site to build it. So start with the foundation. We in I don't go too deep on like theory and books because I think everybody go through these all basic things. I just want to re remember and go to the critical point of whatever we deal with the design part. I just quickly go through that. The foundation is, we know there is two type of foundation: shallow foundation and deep foundation. uh, this is depending upon the ratio of the depth and width of the foundation. This is few types of shallow foundation, which mainly used for building structure as well as some retaining wall, all those things like wall foundation, all those wall foundation, isolated footing, mainly used for building and all those things. But this type of open foundation very rarely used for the bridge structure. But bridge also have some abutment and wing wall. Those wing wall, retaining walls, sometimes use this type of wall foundation. But main structure, which is load bearing from the vehicle and bridge, mostly they go for the deep foundation, mainly pile foundation, oil foundation, or like that. This is I can't say this is less used. This is used for mainly building, and all those type of structure use this type of shallow foundation. This is typical foundation. This is example of combined footing, or this side isolated footing also. So as I say, the foundation, in deep foundation there are few types. These by pier foundation, pile foundation, and oil foundation also. This is mainly oil foundation on site photo. The oil foundation mainly for the long span bridge. Long span means nearly more than 100 meter we consider as a bridge, as a long span bridge. That type of bridge, when pier come the huge load, and also when in the pier come in the water body, mainly on the river or something like that, the well foundation is the preferable choice. This is one construction site photo of well foundation. This is the top view from a water body. By the seat pile, we protect the site from the water to come into it, so we can start work inside that area for the preparing site for the well foundation starting. This is the well foundation, the trap portion, which is go slowly deep into the soil. I go to the next slide. Yes, this is the cross section and view of one typical well foundation. This is the trap portion which is preparing here. This is the concrete, and it is the sharp portion which is start go into the soil, and from the middle portion, which is the hollow portion, from that the soil will be taken out. This is the first stage done. It is just go into the soil. Yeah, bottom plug means this procedure keep on repeating so that it goes enough depth of the foundation. Nearly this oil foundation easily go 30 meter and more than that deep into the river. It is mainly water side. There we can't do the piling work. We choose for this oil foundation. This is the casting of the bottom plug. When the desired design length deep it goes down, then seal the bottom portion and then fill it up. This type of oil foundation very costly, and if it is very much required, only we go for that. I in my 15 years career, one or two times I just see this oil foundation, because it is very costly. If it is very running water body and we cannot stop that water body, so there only we prefer this type of foundation. This is compared to the pile foundation more costlier, so every contractor and everybody try to avoid, because it is only done very big, I say long span bridge, only this foundation is used. And as well as this foundation is costly, and this is also can take huge load, and it support the long span. And other point of view, when we go for the long span bridges, long span means more than 100 meter and longer than that, that is also costliest bridge. So this is seen very less time, but it is the marvel of the engineering. Then come to the most common foundation in deep foundation, that is the pile foundation. This is widely used not only for bridge, it is also used for building foundation also. uh, High-rise building, all those multi-story building, they are also use the pile also. The difference between the building pile foundation and bridge is the size. In building foundation, the pile diameter mainly use 500, 600, 800, 1 meter also. But whereas when the same pile foundation used for the bridge, nearly starting from 1 meter, 1.2, 1.5, 1.8, even if 2 meter dia bore pile also used for the bridge foundation. When pile foundation come into the play, also I forgot like high tension tower, all those very high rise structure which need cannot support by the open foundation or shallow foundation. The pile foundation is the preferable option. For electrical tower, they have uplift pile also, which is specially built and designed to take the tension. And when I talk about the pile is two types. Sorry, mainly pile is two type in construction type of means. One is bore pile and another is hammer driven pile. And most commonly bore pile is can various diameter can be used, means 1 meter, 1.2, but hammer driven pile is also used, but that pile diameter is less, nearly 400, 500 diameter pile, which is hammer driven pile. And pile foundation, the this give the capacity of the structure to take the load. The pile transfer the load to the ground by two method. One is end bearing, another is the friction. S- these two are the load bearing, and means pile transfer the load to the soil by these two method. According to load, how much load is coming on the foundation, means individual pile how much load need to bear to the transfer to the soil. That is the main criteria, how long, how deep pile is goes. In some of the live project, we see up to 23, 30, 30 meter pile length is quite common, and it work at the site also. There is few types of piles, and this is the seed pile. Seed pile mainly used to clear the site for work. Some of the main reason at the water area, some water will come flooded, so worker cannot do the work, piling, pile cap, all those construction need the area to workable for the workers contractor. So if that type of hazards come to the site, then have to go for the seed file to protect the site from the water or all those things. There are some, when pile coming to the top, there is some material wise timber piles, steel pile is also coming to the play, but this type of pile very less used for the structure. But timber pile is quite common use in soil improvement case, slope stability, all those ground work. The timber pile is used for the ground protection, but some of the load bearing temporary structure also used for that this timber pile, but like infrastructure, bridge, metro, railway always rely on the concrete piles. Here the picture of the concrete piles and some composite piles. This is the two methods I earlier told, that piling done either driven pile or cast in situ bore pile. In majority of the cases, the second option, casting board pile, are preferred by all contractors and also all site. It has some advantages because customization of the dia pile, length of the pile, and also when it drilling, it also taking the sample of the soil and also keep updating the soil parameters and SI units, as well as our geotechnical engineer check whether the pile length, whatever the design is okay or need to modify according to live soil data. So this is the most preferable option and widely used option for the pile foundation. But parallelly, driven pile is also there, also used, but there is some limitation. This is the typical step-by-step procedures for the driven pile. Okay, this is the halfway built structure site, that is the shown here, pier and pier cap, and then structure is going on. So now I, other than this foundation part, let's come to the bridge part, bridge design, and that is the my main field where I work for. This is one of the typical structures from top to bottom. Here you can see top there is two U girder. It is taken from one of the metro rail project, Chennai Railway Metro. The top there is two U girder is supported for the metro rail. Typical this type of U girder span is 25 meter, 25, maximum goes to 30 meter. This U girder is nowadays all the metro preferring this U girder structure. These have few advantages. First of all, this U girder is built in one pieces, means there is two U girder, means two pieces for each span, means 25 to 30 meter depending upon the general arrangement of the railway, metro railway. One span is precast and it is fully cast and stored at the yard, and just it come to the site and crane launch it and one span done. This is preferable option for metro railway. This type of U-girder I use in design of Cochin Metro, Chennai Metro, as well as in Malaysia also LRT3. This type of U-girder is used. This is mainly for metro railway because these have flange. So one U-girder to another U-girder vehicle cannot go. So it is typically preferable option for the railway, metro railway. And it when metro railway come, it is the option, not only design point of view but construction point of view. This is the busiest city where we start the metro project, and there is the live road beneath of the this metro. So we cannot stop the all traffic to construct metro railway. What happened at the night time, when traffic is very less, we stop the traffic, and this type of precast fully ready, you gotta come to the site and crane will launch within a single night. Again, from morning open to the traffic, from underneath of this structure traffic keep on moving. So piling, pier, all done. Then for the beam portion, this U beam reduce the site engagement hazardous, shuttering, casting, then curing, all those things, then piece tracing, all those things. No need to do at the site by stopping the traffic underneath. No need to do. Everything is ready. Just come and launch this. You get a structure one span ready. Every night, one or two span launching, like that way. Very fast construction uh, at the busiest location. So this type of U-girder structure is most preferable option for the metro railway, and this is the widely used nowadays. Another thing, the PR cap. PR cap is also precast. It is single piece uh, precast at yard, and this is also launch. Only cast in situ portion is the piling work, pile cap, and pier. It is at the site only. By barricading this work only done. After that, pier cap, bearing, and all you gutter is the precast one for fast launching and fast finish the project. This is the same thing. I just put the another picture from another project, similar type of things. This is for the highway bridge. Highway bridge, we cannot use directly the U gutter because I previously tell that U gutter is specially favorable and suitable for the railway, because railway one up and one down line is, there is no crisscross requirement. Very less one line to another line train will go. That is the we call crossover. That area only we need to specially design. But most of the metro railway one parallelly goes one up and one down. That is very suitable for this type of gutter. But this cannot be used for highway, because highway cars can move, need to move from left to right, right to left, and it need a flat carriageway. We in Malaysia, most of the road, highway, bridge, elevated expressway that use this type of U14 precast beam over that slab, and also this pile cap pier. Up to that, same way cast at the site. Pier cap is precast, and also U14 beam, that is prefabricated precast, that just come and launch. Then only slab need to cast at the site. Some of the typical highway bridge flyover is like this, very wide. One lane, there is two lane for down and 2 lane for up, and total width is nearly 24 and above wide. So this use number of U14 beams, but still it is on single pier. But pier cap so wide cannot be precast in single piece. So that time they have to prefer for the segmental. Here it is 5 segment for the pier cap, and then beam and slab. This type of design is very, what say, very iconic, because single pier supporting so wide bridge is really, really very rare. Okay, other than the conventional and straightforward design, which is pile foundation, pile cap, pier, pier cap, and all the girders, there is some complication come from the site. Come from the site, we designer, we cannot avoid those type of complication. We have to take those complication and we have to give the solution. Sometimes like this, all the load come to the center and goes to the pier and foundation. But for here at the center, there is some obstruction. Maybe there is some water pipe which cannot be relocated, but maybe some crossing where we cannot put our pier to centrally. That time we have to no choice other than go for the eccentric type. This eccentric type obviously other than the symmetric one, eccentric type always critical. And when I say critical, that is design point of view, there will be some extra load, extra moment. So that for I have to design, and that is my job. But other than that, from contractor also try to avoid this, because whenever the extra moment, extra load comes, it become extra reinforcement and extra everything, and that cost contractor also to build the structure, and this also affect the project cost, and all those things come into the play. And other than that, not easily we go for this complication. Other than the cost of this individual pier, pier cap also cost extra involving shuttering. Like that, these type of structure have number of repetition. So one, they construct the mold that will can be used for number of times. So that will be more easy for construction, and repetition work will help faster way. But this type of structure come into the play is the single piece, and for this mold preparation and design, everything become only for one pier. So everything cost high to the project. Like this type of difficulty when come, but we have to accept the every side don't have clear land to put straight cut design and simple design repetitive way. Like we know that there are very city, this is already crowded. From that crowded city, we try to do new flyover, new highway, connecting highway, metro railway. So definitely there will be some obstruction will come, and we have to we have to solve from structural point of view, from our designer point of view. We have to give the solution. how at the site they can construct. So this type of irregular structure will come into the play, and we have to encounter like that. This is the simple eccentric pier. Then next come, this is for the metro railway. One thing is that sometimes it's called extended pier cap. What is that? We earlier say U girder for railway is used, but sometimes this U girder cannot be longer than 25 meter, or some of the cases 28 meter. For project to project, they prepare the mold and casting procedure such a way that U girder is designed for one optimum length. Maybe some of the project that is 25 meter, some of the project 28 meter, but that is the fixed for that project. So all U girder is maximum length can be up to that much, but some of the places you pier cannot be placed within 25 meter. There is need to some elongated gap, means 26 meter or 27 meter, then again 27 meter, then again start 25 meter. So for those two span 27 27, the U girder cannot be fit, as U girder maximum length is 25 meter. That is the standard. But if we go and try to build 27 meter U girder, that will be more costlier than this solution. This is the pier cap that extend both the side to support the U girder. It is elongate both the span, means if it is 27 meter, then 2 meter extra length. It arm goes fast pair to uh, increasing chainage to decreasing chainage, so that that 25 meter U girder can fit and continue the track. So this is the special type of pier which is called longitudinally extended pier. Then portal. It is very common and simple portal when at the middle of the road there is no place to we can put the pier, then go for the portal. This is most common simple portal that both the side we have portal pier and portal pier supported by the pile foundation. But these type of simple portal also not possible. Some of the complicated and crowded area, some utility is there, like this. This is something between portal and the single cantilever pier. If it is single cantilever pier, the top portion should be equally cantilever both the side. But here where the pier location we can allow to cast the pier, that is not exactly center of the carriageway. One side it is total width is 28 meter, but you can see at the top one side is 2 lane is 7.3 and another side is 11 meter. So unbalanced load is there that single pier cannot take. So it need to be portal, but it is not as previously shown like simple portal that extreme two end two legs are there, not like that. Here definitely at the far end there is only one pile go up to the top to support, because far end there will be very less load. But At the central portion, there will be very much vertical load, but that is hello. Yeah, that is individually cannot support of this unbalanced load. At the if it is become single pier, there will be huge moment, and that cannot be support by the single pier. So the secondary leg which make it portal required, but that bear very less vertical load, but still it is required. Because of this portal action, the moment at bending moment at the center of the pier become very reduced, and that way we have designed that unbalanced carriageway with two legs. One type of portal is this. This is also, you can say, portal, but thing is that there is one centrally carriageway which can be beared by the single pier, but there is another ramp is coming, and also that is not in the same level, because you know that uh, as well as we design for the highway, there is also level requirement. If that is going down, going up, we cannot make it same level as we wish, because some of the roads going slowly down and merge with the another the add grade level, and some of the flyover going up cross the some railway, some other road, then it will go down. So there is level is one of the important role. If level is not matching, then we have no choice to build like this type of complicated and funny type of structure. But this is the most optimum way. If we make try to make the two levels same, that will be very difficult for the furthermore way, because one of the carriage ramp is going down, another highway is going up, so have to maintain the level. So this type of funny structure come into the play to design. Here is also double decade. One is the lower level, another is the upper level. One is coming up, one is coming down. So double level portal is common, but sometime same way some utility or some site constant make this portal one type of like P type structure. One side the vertical load from top to next level and go to the ground straight away, but other side from top to bottom, but from first level it cannot go down, it have to be shift some left or right and then go down. Definitely that bottom bottom part of that pier uh, concentrated all vertical load movement, and it become critical, but there is no other choice than simple way. We can go back to simple structure. This is look like quite expected simple way, but still we can see like previous one, the right side, there is some requirement that deck width need to be so much, so the pier cannot be continue from top to bottom, it need to be shipped by some 2 meter or something like that, which leads to be non-symmetric way of the load distribution. But this type of structure, some of the project come but we have to encounter from our design point of view, whatever the moment and loads is coming, we have to satisfy and check the design and need to provide for the construction. Same thing. Okay, this is also the structure construction point of view. Have to say this is not all construct at the site. Some of the requirement to make it fast, and also earlier say this type of flyover where we don't go to build at the vacant site. Definitely there is requirement of highway, and flyover is the busiest way of the city or busiest road need to be replaced by the new flyover, connecting flyover. So definitely expected at the ground that is not empty, that is one of the busy street or full of utility or something like that. So the requirement of the this type of construction of the portal cannot be done, uh, such a way that at the site will be blocked. So the this level of portal is precast at the site at section F. You can see the U type of the portion is the precast and bring and put at there, then fill up with the concrete second stage and latter stage to build the portal pier cap, then put the beam and go with the structure. This is shown here step by step how double deck portal built. First pile cap and pier up to first level, then bring back the precast one and put and cast filling up, then place the beam of the first level, then column going up to the second level, then second level built, and same way it goes. Something we have to provide for the contractor when it is not symmetrical, then first level will cast with the support of temporary support, and first level build completed, then go for the second level of build. This is the stage by stage how the portal built at the site. Okay, we discuss about the various type of portal supported by the pile foundation. Some more complication comes into the play when the portal need to be built over a ground. Under the ground there is one of the tunnel called smart tunnel, which is the flush out the rainwater, all those things. And this tunnel is beforehand, means it is long before it is constructed, and we cannot touch the tunnel portion. It is come under the water sewage water supply, means drainage authority and higher authority want to build the new flyover, but that exactly come where we want to build the flyover at the ground level. Below the ground 12 and 13 meter below there is the tunnel, and we cannot disturb the tunnel because it is functioning the wastewater. So when we go for the portal and pile option, there is some restriction. We here we show that from the tunnel there is some tunnel protection control line, which is vertically 45 degree angle it goes to the ground. Those portion of soil we cannot use for those portion of soil. We cannot transfer the load from pile to the ground. If we just simply driven the bore pile and do the structure, the load immediately after the pile start dissipating the load from pile to ground. And if in this zone, means above the tunnel zone, if pile transfer the load to the soil, then that can be disturbed to that tunnel. And we don't know how strongly built the tunnel can able to take the new structural load which is come through the pile to the ground to the tunnel. Whether it will disturb or not, we don't know. So we have to avoid this type of structure. We cannot avoid the pile location, but we have to avoid the load dispersion from the pile to the soil. So some of the special technique our geotechnical engineers suggest and we apply, that pile should be line up, means one of the cover will be provided pile up to that tunnel control line, means half depth of the tunnel, so that pile will be freestanding from that much of height, and pile will not disperse the load to the soil as a friction soil. After the tunnel portion, pile can disperse the load, and at the end it may be end bearing pile, but top portion of the pile should be separated from the soil, so that portion of the pile just stand alone and no load distribution to the soil, so that the existing tunnel do not disturb or do not take any more further load from the new structure. So after that, which happened, that tunnel collapse, and drainage authority blame to the higher authority, your new structure collapse my tunnel, now full city is flooded, and something like that. So we have to take very precaution for this type of construction. And also design point of view, we have to measures all those things. Another thing, double decker structure, but we don't have space for the portal. Top one supported by the two columns side by side from the bottom, and from the lower level it comes single pier option. This option we called as lollipop pier or lollipop structure, which is two level of roadway, which supported by at the bottom is a single pier. Same type of structure try to build at the side, but there is some site issue come, and same way at the top one highway and bottom highway, the center portion we cannot place the exactly center portion, we cannot able to place the pier. So another side at the side one pier is required, so it become portal. Means this is one of the I ever seen in Malaysia. Lots of place they use this type of lollipop structure, means two level flyover, but not a portal. It's at the ground it is single pier. This is also at the smart tunnel area, and also two level of viaduct at different level. So it like portal over small portal over the bigger main portal. this type of structure is built, but easily we cannot put at the middle one more pier because there is smart tunnel. So we have to avoid the smart tunnel area. So first level pier cap become very heavier because it is at the middle supporting another small pier who is supporting the upper level of the viaduct. This is one of the design I do. You can see there is only place one row of pile. You don't consider this is a single pile. One pile, this is the cross section view. One, there is row of pile. There is 3 or 5 number of piles. I can't remember exactly. This is the pile central line and pier central line. There is some difference. There is eccentricity because there this side there is smart tunnel and other side there is some electrical or water pipe is coming. So pile exactly center of the pier we cannot place. For this there is huge movement coming when we design the pile cap, because pile center line and pier center line is not same line. It looks like very common structure, easy structure, but somehow there is some twist. Okay, this is the one of the mix type of portal. It is I do in the Chennai metro. There is called one Mute flyover. You can see at the top, that is the railway from Chennai metro railway. It is this structure come under the railway, but same level there is at the ground level. There is two road and also their flyover higher authority want. There is one Mute flyover. One is up, one is down. So that flyover need to be support with the same structure. So at the middle level there is, you can see this is I girder supporting the highway traffic loading, and at the top there is metro railway, Chennai metro railway to U girders, and this is the single pier at the middle, that is 2.5 dia circular pier and supported at the pile foundation. This type of structure, when we go for the design, we have to struggle with this. First of all, at the Indian code, IRC is the Indian Road Congress. It is at the Chennai Metro project, so have to follow the Indian code. For highway point of view, we have to satisfy all the requirement from the IRC code, and also it support the railway also. So we again same the structure. We have to check with the railway code to satisfy all the requirement from the railway code. So same structure we have to check with the both the code to satisfy the both the authority, highway authority and the railway authority to get approved of this type of structure. And after that only we can issue the complete the design and go for the and present to this supply this drawing to the contractor for construct. But before that have to go to different authority, and they thoroughly go there. Not only they see and approve because their load is bearing this structure, so we have to go total approval, means total satisfaction of both the codes to to get a single design approved. This is our typical GA drawing when flyover or metro railway goes. you can see this is really, when I say I am bridge engineer, everybody expecting a bridge means a structure which cross the road, cross the river. In the middle will be water and two bank and connecting structure from another bank to another. But frankly speaking, on the river bridge, I do very less rather than this type of flyover and metro railway. First of all, I show you that well foundation, all those mainly required for that river bridge means very wide river bridge. But this type of flyover, mainly main challenging is not the water, not the river, but main challenge is the, you can see both, this is the one road at the ground, both side will be shop or house. In between this road, the authority want to construct one flyover or one metro railway. There is very challenging to place the pier location, and those type of complicated portal with leg at, not at the middle, some eccentric way, all those things will come into the, this is typical abutment type when roadway into the flush to the ground or something, then this type of abutment structure will require, which is supported by one row of pile, and after that the traffic will go to the ground. This is the transverse view of that abutment. You can see left side, it is from bridge beam supporting to the abutment and loads goes to the pile. After that the approaching slab and retaining wall. After that the fill up work and on ramp, then traffic goes to the on ground. This is the typical, that challenge I told you, that smart tunnel, we have to debonding length to the provide to the pile, so that the pile do not transfer the load to the soil above the smart tunnel, which load come back to the tunnel and which may disturb the tunnel. This type of solution is provided by our geotechnical engineer, so that we satisfy the requirement of the authority of owner of the smart tunnel, so that we can allow to build the structure around the smart tunnel without disturbing that, and we can construct the infrastructure new highway. This I just discuss about the all about the above substructures. Now come to the foundation. Foundation, when I call foundation is two things consist of foundation: pile and pile cap. This is a typical 4 pile or 5 pile or 2 pile cap, very regular shape and size. This is we ideally design for all the structures. First point, we are, our priority will be every pile and pile cap will be regular and evenly distribute all the load coming from the superstructure, substructure, pier to the pile cap, evenly distribute to the all pile. This is the first choice of a designer to get this type of foundation for my structure. But the situation, location, and some utility and some congestion at the site force us to go for asymmetric one. First of all, like this, we have 4 pile, but pier at not at the center. It is towards the 2 piles. Even this will lead to 2 pile will be more loaded and another 2 pile will be very less loaded. Irregular shape. This is quite common when so many utility mean when survey it cannot be seen. When contractor come and try to dig for the piling, then they only found inside the buried soil there is some water pipe, some high voltage electricity, some of the cable, optical fiber, something like that. Wastewater drainage and water drainage easily can be found. It is under these, so we can avoid. But still, those in the survey, but some of the thing get missed. And when we go for at the site, then we found there is difficulty to do the regular pile cap. So some of the rectangular 4 pile group become some rhombus or trapezoid like that. This is the irregular pile group. When this type of pile group come, then definitely when checking for the pile cap will be very difficult. First of all, load will be come from the pier to the 4 pile is not equal. It have to be calculated some rivet theory or some of the geotechnical engineer they use Plaxis and some other software to calculate the load distribution among the 4 pile. Then moment and shear, punching shear need to check for the pile cap. For this type of irregular pile cap, need to do very correct way to calculate the pile load distribution and all those designs. Same way, one pile deviated from the his original location. Last time what I explained that is not the one pile, maybe one series of pile, maybe 5 pile. You can see that top one, that is the regular 5 pile group supporting one column. But second one, there is something we cannot place the 5 pile at the line of the pier. There is some deviation, some of the skewness, some of the angle. So when we calculate from the superstructure load, there will be one longitudinal moment, one transverse moment. All need to be factored with this angle and have to check properly because all the pile is not same direction with the traffic. There is some deviation due to some site constraint. Same way, there is something which cannot be lead to 5 pile group, a regular 5 pile group. This irregulation of this type of pile cap is come to us very frequently when at the site construction is going on. So with very limited time, we have to check and do give the feasible solution for the location. Sometimes it not for the utility. Some of the at site they boring the pile halfway, they stuck the bore cutter or something which cutting the soil stuck in halfway, cannot be move out, cannot be go deeper. In that situation we have there is no choice other than the leave the pile location. At that time we also go for the alternative pile location to satisfy the foundation. Similar some here we can see there is some pipe and which cannot be avoided. So contractor proposed that pipe will be inside the pile cap and they can do construct. We have checked if there is one hollow in the pile cap, that will be satisfied or not. We have checked and proposed same way, and they have construct like that. Pile cap looks like quite regular, but inside there is one pipe which is make it non-structural pipe, means that is make pile cap hollow, and it should work with is working load. This is some of the irregular pile, and this is also, you can see the first, there is three pile, but three pile spacing is not equal because of there is some utility or something is there. So this type of uneven distribution leads to some pile have more load, some pile have less load, but for the requirement we have to do. Okay, this is how many varieties of structure we have discussed, but how we calculate, we we want to see some of the things. When we design the bridge design starting from the grillage of the superstructure, means beam, slab and parapet is there, and above that there will be some traffic load will goes on. This type of grillage structure we do in the StatPro, and at the bearing location we put the pin support, and from that for the superstructure the bearing reaction we calculate for the dead load, self weight of the beam, slab together with dead load, and SIDL nothing but the wiring course, the layer of the bituminous structure above the concrete slab provided like any flyover everybody can see, and parapet weight. This is all SIDL, and then live load, those all at the bearing reaction from the left, one of the span left side and one of the span right side. This is the bearing reaction we extract from the stat group. Then another thing, we need to calculate the wind load as per BS, and we all the structure, what is the wind force is acting, we calculate that. And the seismic at this Malaysia, there is quite straightforward seismic option. There is the 0.5 G as per design. In India, there is, for this factor we have to do lot of calculation, and here dead load, SIDL and all those live load with 5%, what will be the seismic load, easily we can estimate here. And here is the, when bridge structure, one type of portal, three-legged portal, two-legged portal, and some, it is the series and it is connected with the beam, one span to another span, another span, and so the longitudinal load like one car brake, and this longitudinal braking force come to the structure, it not only come a single pair, it will distribute over few pairs. There will be connectivity between one span to another span with link slab, but there will be some of the movement joint. So movement joint to movement joint, these longitudinal load will distribute it. Not only the braking force, for example, braking force, seismic of longitudinal force, and also longitudinal wind force, creep and sinkage, all those force will distribute it over the few span. And for this analysis, this type of model we done at the StatPro, and all those longitudinal force apply and then distributed over the few periods, and result comes some horizontal distribution like this. Means one of the pier there will be creep and sinkage, temperature, breaking, earthquake with permanent load, earthquake with HA load, HB load, wind load at erection condition, no live load, wind load, and with live load, wind load, all those distributed over few numbers of PR like this way. And after this, the longitudinal force we calculated, and as well as from grillage analysis, we bearing load we calculated that apply into the portal model and bearing location and analysis the portal. Then we design the PR crosshead, as well as from this support we get the foundation load. At one foundation, how much load will come. This is the boundary condition, and this is one type of foundation load when finalized for SLS case, ULS case, and unfactored case. It is required for pile capacity and all those things. So these three cases foundation load we prepared, and this is given to geotechnical and engineer to check the pile capacity, and then they give back the pile reaction. Then we from that load we check the pile cap design. There is few of the calculation as per code, that ULS check, SLS check, punching CR check, all those things when carried out, and finalize the reinforcement that provided in the drawing. And accordingly, the contractor will start the casting all those things. This is the one of the our software that is structural stat. Other than StatPro, this is the SAM for checking the section capacity. This is the SAM output when we check the section with our software. And also we have in-house spreadsheet that is widely used for the checking all the capacity of the pile cap. That is the very less briefing way to calculation. That's all. Any question anybody can overall can ask. I
Thank
don't
you.
go into the deep of anything design, how moment is calculated, how CR is calculated. All those things can be in code and in books is very good way. But in overall on project, what are the problem and how to take we are a designer, we cannot say okay there is some pipe, you can ignore it, that much concrete is not required, you cut 2 bar and put it concreting. We have to, whenever anything expect from us, we have to give the solution in written report format, and that is as per code is easy, it is passing and it is adequate and it is not failing. We have to give that type of written certificate whenever we give any drawing, even if that is so called shape is so funny, but have to structurally uh, approved by the code we have to see that top, that thing. That is our target.
Jayanto, thank
Yes.
you. Thank you very much. Actually, what I can see, you are not only senior bridge engineer, actually you are the bridge yourself between academia and real life construction, construction of bridge. Jayanto, we love you. Actually, your presentation was so resourceful and you dealt with the practical things, practical cases, which are in real life in Chennai, in Malaysia. So you are so wonderful and magical.
Okay.
You
Thank
will
you.
be
Thank you.
very, you'll be very big speaker someday, expert speaker. This is a start. I can see Jayanto. We love you. Okay. Thank
Thank
you,
you. Thank
Same
you.
Jayanto.
thing, Jayanto. Devmala Roy here. It was a very useful and resourceful session, and I also really enjoyed the whole part. I couldn't join, but I joined since last 1 hour. It was very useful
I-
topic, and I think the people who have joined, they have really gained some knowledge
Yes,
out of it.
Thank you. Thank you,
Great,
Detmala.
great, Jayanto, great.
great, really great. I didn't went anywhere. I didn't go anywhere. Constantly, I'm sitting and listening you, my dear. You are so good because I can see real life project. So I'm getting interest. You know, so that is what actually you need to do as an industrial expert. What is the connection between theory and that field life or field cases? So you did that job very nicely. Very good, wonderful. So
Thank you.
Krishna,
Thank you.
Yeah. So I would like to add some things. Really, it was a very wonderful session. And lastly, I just want to say that it is with a great gratitude and appreciation that I extend my heartfelt thanks to our distinguished speaker, Mr. Jayant Kumar Nath, for delivering especially such a insightful and engaging session today. We sincerely appreciate the time and efforts you took share your knowledge with us, and definitely your ability to break down, as General Sir has already mentioned, that especially complex structural concept into a practical to the real world, I mean, the real field application. That was a very wonderful. And once again, thank you very much for your time. And we hope to have more such enriching session with you in the future.
yes,
So
Okay.
definitely.
Thank you. Thank you.
we will not let you go. So, dear participant, if any of you are having doubt, please you can ask.
Yes, this is now open for the question and answer session. So we'll have at least, I think we can have 10 minutes. So
Yeah.
if you need any doubt, any questions, any queries, you may ask.
In Malaysia, what is the time, Jayanto? After
2.5 hours, maybe
11:30.
11:30, so it's midnight almost.
Yeah.
So you need to sleep. Sorry. Uh, quickly, are there anyone having doubts? So all are actually exhausted because all the people they are doing the job, doing the work
application.
all day, and after coming they are attending this, so all are like exhausted. So that's all. Let us end here. So let us give everybody good night. And Jayanta, thank you very much, very much.
Thank
Okay,
you.
Okay. Thank you. Thank you.
thank you. And
So good night.
Thanks,
Devmallo,
thanks. Bye. Good. Bye, bye, Jayanto.
bye.
Okay. Bye.
Yes, good night, everybody. We'll see
Good
you
night.
in
Good night.
tomorrow's.
Good
Yeah.
night.
Shall I end?
Yes, you can end. So good night, Jayanta.
Okay.
Bye bye.
Bye.
My goodness.